So in this problem with a lot of algebra, if m is the square of an integer, which numbers must also be the square? Keyword must here. And we have to select all that apply. So there could be more than one correct answer. So the first thing we want to do is think about what m is. Well, m is the square of an integer. So let's say if that integer is p, we'll do p squared. And let's come up with a value for m as well to use in web testing. So let's say p equals 2, then m is going to equal 2 squared, which is 4. Now there are two ways to solve this problem, an algebraic way and a plugging in numbers way. But you don't have to stick to one solution all the way through, and sometimes you may want to just do a hybrid solution where you use parts of both. Like for here, in answer A, 6m, it's much easier to plug in a number, say m equals 4, that gets us 6 times 4, which equals 24. 24 is not a square, so that a doesn't have to be the square of an integer. A is incorrect. B. So here, since the algebra is a little more complex, we want to use an algebraic way of solving it. So let's think m equals p squared. We can write this as 9p squared plus 6 root of p squared plus 1. So let's get rid of that radical and the square there. So we're left with 9p squared plus 6p plus 1, and that is something we can factor. So I'm going to put a 3p on both sides, and since we have a 1 here as our constant, we know that both these are going to be 1. So 3p plus 1 times 3p plus 1, that's 3p plus 1 squared. And since p is an integer, this whole thing must be an integer as well. So we've proven that in all instances, b will yield the square of an integer, so b is correct. Lastly, we're left with c. So squaring a square, this might get a bit messy, so let's plug in that 4 again. So we have 9 times 4 squared plus 6 times the root of 4 plus 1. So it's going to be 9 times 16, which is 144, plus 6 times 2 plus 1. This is 12 plus 1 plus 144, which gets us 157. 157 is not a square, so the answer must be B.